guys, myself Prem and I'm studying class 12. So now let's talk about partial fractions of class 12 maths 2A. So before going to partial fractions, let us discuss about rational fraction. Rational fraction. Okay. So rational fraction is nothing but, let us assume that if f of x and g of x are are two polynomials and g of x is not equal to 0, then f of x by g of x is called a rational fraction. Okay, so for example, let's take 5x plus 1 divided by x square minus 3x plus 2, or we can write as x cube plus 2x plus 1 divided by x square minus 2 are two rational fractions. Okay, so rational fractions consist of two types. One is proper fraction, and second one is improper fraction. So now let's discuss about proper fraction and improper fraction. Then we can discuss about partial fractions. Okay. Proper fraction. So proper fraction is nothing but if f of x and g of x are two polynomials and g of x is not equal to 0, then oh wait, sorry. So proper fraction is nothing but a fraction f of x by g of x, where g of x is not equal to 0, okay, is said to be a proper fraction if and only if degree of f of x is less than degree of g of x. Okay, which is nothing but the degree of numerator should be less than the degree of denominator. Okay, so let's write an example. X minus 2 divided by x square plus 2x plus 1. So in numerator the degree is 1, and in numerator the degree is 2 plus 1 is nothing but 3. So 1 by 3 is nothing but proper fraction. Now let's talk about improper fraction. Improper fraction. So improper fraction is nothing but a fraction f of x by g of x where g of x is not equal to 0. Okay, is said to be a improper fraction if and only if degree of f of x is greater than or equal to degree of degree of g of x. Okay, so let us take an example. X cube plus 5x plus 3 divided by x square minus 1, or so the degree in numerator is nothing but 3 plus 1 is nothing but 4, and in degree in numerator is nothing but 2. So 4 by 2 is nothing but an improper fraction. Now we can write as x plus 2 into x plus minus 5 divided by x square minus x plus 1. Okay, x square minus x plus 1. So these are some kind of proper fraction and improper fractions. Okay, now let's discuss about irreducible and reducible polynomials. And irreducible polynomials. Okay, so a polynomial f of x is said to be a if said to be irreducible if it cannot be expressed as product of two or more polynomials. Okay, so this is irreducible polynomials. And about reducible polynomials, which is nothing but a polynomial f of x is said to be reducible if it can be expressed as product of two or more polynomials. Okay, so for example, x cube minus 1 is nothing but, so it is in a form we can write this as a minus a cube minus b cube, which is nothing but a minus b into a square plus ab plus b square. Okay, we can reduce this equation into this polynomial into two parts. Okay, so x minus 1 into x square plus x plus 1, and we can take another example as x plus 1, and we cannot reduce this into two or more polynomials, so it will be the same. This is reducible and this is reducible. Okay, now let's talk about division algorithm. Division algorithm. Okay, division algorithm. If f of x and g of x are two polynomials with g of x is not equal to 0. Okay, then unique polynomials q of x and r of x, then they belong to q of x plus r of x, which is nothing but quotient and remainder. So total f of x is equals to g of x into q of x plus r of x. This is division algorithm, or we can write as f of x by g of x is equals to q of x plus r of x by g of x. Okay, these two equations are known, we can write. Okay, this is about division algorithm. Now let's talk about partial fractions. So partial fractions is nothing but a proper fraction is expressed as a proper fraction is expressed as sum of two or more proper fractions, where in the denominators are powers of irreducible polynomials. Okay, then each proper fraction is called a partial fraction. So they meant that a proper fraction is expressed as sum of two or more proper fractions, where the denominators are the powers which are irreducible. Irreducible. Okay, then each proper fraction is called as partial fractions. Okay, now let's discuss partial fraction rules. Rule 1. So rule 1 is nothing but g of x contains non-repeated linear factors. G of x contains non-repeated non-repeated linear factors. Okay, G of x contain non-linear factors. Okay, so let f of x by g of x be a proper fraction. Okay, be a proper fraction. Then we know that formula f of x by g of x, okay, is nothing but, sorry, this proper fraction is equals to f of x by x minus a into x minus b. Let this be a proper fraction. So we can write this as a by x minus a into b by x minus b. Okay, this proper g of x is converting into two polynomials, and these two polynomials are being separated. This is rule number 1. Okay, now let's discuss about rule 2. Rule number 2. Rule 2. So in rule 2, g of x contains repeated linear factors. Okay, g of x contains repeated linear factors. Okay, so let f of x by g of x be a proper fraction, which is f of x by x minus a whole power n, or whole square. Let's take as whole square. Then we can write this as a1 by x minus a plus a2 by x minus a whole square, so on up to a power n divided by x minus a whole power n. This is about wait, these are two rules. Now let's talk about third rule. Let's talk about rule 3. Rule 3. So rule 3 is nothing but g of x contains non-repeated irreducible non-repeated irreducible factors. Okay, it contains non-reducible irreducible factors. So let f of x be a common proper fraction, and ax square plus bx plus c is an irreducible factor. Then f of x by g of x is equals to f of x by, this is an irreducible fraction, then we need to write it as ax plus b divided by x square plus bx plus c. Okay, and we need to find a and b constants. This is rule 3. Now let's talk about rule 4. Rule 4, it is nothing but g of x contains repeated irreducible factors. Repeated irreducible factors. Okay, so g of x contains repeated irreducible factors, which is nothing but let f of x by g of x be a proper fraction, and ax square plus bx plus c whole power n is a repeated irreducible factor. Then we can write as f of x by ax square plus bx plus c whole power n. We can write it as a1x plus b1 divided by ax square plus bx plus c plus a2x plus b2 divided by ax square plus bx plus c whole square up to n terms, up to n terms, plus b n divided by ax square plus bx plus c up to n terms. Okay, and we need to find the values of a1 b1 a2 b2 respectively. Okay, now let's go to rule 5. Okay, so rule 5 is nothing but a partial fraction of f of x by g of x when f of x by g of x is an improper fraction. Okay, so let f of x by g of x be a improper fraction. Okay, let it be a improper fraction. Then there are two cases. Case 1. Okay, then case 1, degree of f of x is equals to degree of g of x. Then by division algorithm we can write as f of x by g of x is equals to k plus r of x by g of x. Okay, where r of x is equals to 0 or degree of r of x is less than degree of g of x. Now let's talk about case 2. Case 2. Okay, so case 2 is nothing but if degree of f of x is greater than degree of g of x, then division algorithm there exists such that f of x by g of x is equals to q of x plus r of x by g of x. Okay, where r is equals to 0, r of x is equals to 0, or degree of r of x is less than degree of g of x. Okay, these are the two 5 rules in partial fractions. I hope you all guys understand. Thank you. If anyone has doubts, please comment.